Texan Global School. Trigonometric functions. In this class, we will analyze the trigonometric functions on the Cartesian plane and their ratios. The first concept that we will see is the angle in standard position. It is the one in which its vertex is at the origin of the Cartesian plane, and its initial side is placed on the positive side x-axis. We can see on the board that given a point in the plane, we can have an angle in standard position, theta, in a counterclockwise or positive direction, or clockwise or negative direction represented as omega. There are 6 functions called trigonometric functions: sine, cosine, tangent, cotangent, secant, and cosecant. The trigonometric function notation is represented from a given angle as shown in the table. The sine function evaluated at the angle theta, or simply sine of theta. The cosine function evaluated at the angle theta, or simply cosine of theta. The tangent function evaluated at the angle theta, or tangent of theta. The cotangent function evaluated at the angle theta, or cotangent of theta. The secant function evaluated at the angle theta, or secant of theta. And finally, the cosecant function evaluated at the angle theta, or simply cosecant of theta. Each trigonometric function is associated with an angle in standard position and a ratio between the sides of a right triangle. We start from the point of coordinates x, y in the Cartesian plane. The distance between the 0, 0 point or origin to the given point is called the radius vector r, which generates an angle in standard position theta. From this angle, we have 2 distances given by the abscissa x and the ordinate y. We can see that a right triangle is formed from the angle in standard position theta and the given coordinate point. Then, the value of the abscissa x represents the measure of the adjacent side, and the ordinate y represents the measure of the opposite side to the angle. The hypotenuse is the radius vector r. From any right triangle, the following trigonometric functions and their ratios are true. The sine of theta is equivalent to the opposite side over the hypotenuse. The cosine of theta is equal to the adjacent side over the hypotenuse. The tangent of theta is equal to the opposite side over the adjacent side. And let's observe that the cotangent of theta is the reciprocal of the tangent, that is, adjacent side over opposite. The secant is the reciprocal of the cosine, that is, the hypotenuse over the adjacent side. And finally, the cosecant is the reciprocal of the sine, which is equal to the hypotenuse over the opposite side. The mnemonic SO, ka, TOA is helpful for remembering the definitions of the trigonometric functions, as sine opposite hypotenuse, cosine adjacent hypotenuse, and tangent opposite adjacent. The angle of a trigonometric function can be calculated in several ways. One of them involves estimating its value from a circumference, as shown on the board. We can see that with a counterclockwise direction, the degrees start at 0, 45, 90, 135, 180, and up to 360. However, the angle of a trigonometric function, given at least 2 sides, can also be calculated by isolating the angle and calculating its value using the scientific calculator. Using a scientific calculator, the value of an angle can only be calculated with the sine, cosine, and tangent functions. To isolate the angle, we must use the inverse function called arcsine, arccosine, and arctangent, respectively. In the calculator, the second function, or the inverse of each trigonometric function, is used to obtain the angle. It is very important to place the parentheses of the function argument. It is also essential to verify that the calculator is in deg mode so that the result is delivered in degrees. If it is in rad, the result will return it in radians. Let's see an example. We will find the trigonometric functions given the point P of coordinates 1, 1. Also, we will calculate the angle. First, it is essential to draw the right triangle from the given point. As seen on the board, the abscissa is the adjacent side equal to 1, and the ordinate is the opposite side, in this case, is also 1. Using the Pythagorean Theorem, we can calculate the value of the hypotenuse r. By substituting and isolating c, we see that the hypotenuse is equal to the square root of 2. Then we obtain the trigonometric functions with their ratios. Sine is 1 over the square root of 2. Cosine is 1 over the square root of 2. Tangent is 1. And now the reciprocals. Cotangent is 1. Secant is square root of 2. And cosecant is square root of 2. Now we solve for the angle. Remember that we can only select the sine, cosine, or tangent. In this case, we will choose sine. So we isolate the angle theta as arcsine of 1 over the square root of 2. let's use the second function on the scientific calculator and specify the parentheses. Then results that the angle theta is equal to 4 to 5 degrees. Finally, we draw the right triangle with the calculated data. In this other example, we will obtain the trigonometric functions with their ratios if the secant of theta equals 2. We will calculate the angle as well, because the secant of theta is equal to the hypotenuse over the adjacent side. If the secant of theta equals 2, the numerator is 2 and the denominator is 1. Therefore, the hypotenuse equals 2 and the adjacent side is 1. We draw any right triangle. The right angle is always the opposite angle to the hypotenuse, in this case, equal to 2. So, if we define any of the other two angles as theta, the adjacent side is equal to 1, and we have to find the opposite side. If we draw the triangle on the Cartesian plane, we can see that the adjacent side, the abscissa x, equals 1, and the radius vector r, that is, the hypotenuse, equals 2. Then we must obtain the ordinate y, that is, the opposite side, by applying the Pythagorean theorem. Substituting values and isolating results that the opposite side equals the square root of 3. So, since the hypotenuse equals 2, the adjacent side is 1, and the opposite side is square root of 3. Hence, we can obtain the trigonometric functions and their ratios. Sine is square root of 3 over 2. Cosine is 1/2. The tangent is the square root of 3. And now the reciprocals. The cotangent is 1 over the square root of 3. The secant is 2. And the cosecant is 2 over the square root of 3. Now we will solve for the angle. Once again, let's remember that the calculator only has sine, cosine, or tangent. In this case, we will choose the cosine. So we isolate the angle theta as arc cosine of 1/2. Then we enter the data by using the second function on the scientific calculator and specify the parentheses. Hence, we obtain that the angle theta equals 60 degrees. Finally, we can draw the right triangle with the calculated data. We will analyze the following problem. Two little brothers were playing with a kite in the park, which got stuck in the highest point of a tree. To get down the kite, they must place a 12-foot ladder from the ground to the top of the tree. The angle generated between the ground and the highest point of the tree is 30 degrees. What is the height of the tree? The first thing that we must do is to sketch a triangle representing the given conditions. Now, let's analyze. The ladder is the hypotenuse with a length of 12 feet. The tree's height is the opposite side of the given angle of 30 degrees. Which ratio of the trigonometric functions involves the hypotenuse and the opposite side? The sine, since the sine of theta, equals the opposite side over the hypotenuse. We substitute the values, obtaining that the sine of 30 is equal to h over 12. So, let's isolate the height h. The denominator is cancelled by multiplying both sides of the equation by 12. Now on the scientific calculator, we type directly sine of 30, resulting 1/2. So we multiply this result by 12, resulting in the tree height being 6 feet. Texan Global School. Global online learning. Knowledge for the world. www.texanglobalschool.com